second step is basically to solve all the equilibrium equations. Now here, since I am into D, I have three equations. The first one is sum of fx is equal to 0. The second one is sum of fy is equal to 0. And the third one is sum of m is equal to 0. Now what you should know, guys, sum of fx is equal to 0 means that I should find the projection of the forces in x direction, and I should find sum of fx is equal to 0, which is very trivial. Same goes for sum of fy. However, guys, for sum of the moments, this equation is applied on any point on the beam. So you can take the first point, the last point, the middle point, any point of the beam must satisfy this equation that states that the sum of moment around O is equal to 0. Now guys, what is very important to know is that sum of moments is equal to 0. It is recommended to take this equation and apply it on one point, which is the point of intersection of two unknowns. Like this case, guys. Here, I know that AX and AY are intersecting on one point, which is A, because basically the reactions are at A. Which means, guys, if I take the sum of moments around A, I can get rid from two unknowns that are AX and AY. And then, guys, I can find MA. So this is a method to get rid from two of three unknowns, because basically, as you can see, I have three equations, three unknowns. What are my unknowns? AX, AY, MA. So this is a method that will facilitate my problem, and it is by getting rid of the reactions that are intersecting on one point where I'm finding the sum of moments. So guys, basically, I can start with the sum of moments, and I can get rid from AX and AY by doing it on A, and then I can find MA. And then, guys, I can go to sum of fx, find AX, go to sum of fy, find AY, and in this case, I can find all my unknowns. So I have three equations, three unknowns in the case of 2D. Okay, so I will take basically the sum of moments around A is equal to 0, and I will assume that the clockwise direction is positive, which is basically the direction chosen for MA. And here, guys, I forgot to tell you very important note. So you can take any direction for your unknowns. And now, guys, when you found your unknown, if your answer was positive, this means that you have chosen the correct direction. And if your answer is negative, then you should flip the direction of your unknown. Okay, so what are the moments of the forces exerted on A? Basically, I have MA. So MA means this reaction here. So this is MA, guys, okay? MA is in clockwise, so I will take it in the positive direction, okay? Now, what about 1200 and 981, AX and AY? First of all, guys, AX and AY will not have any moments on A because they are intersecting A. And that's why, guys, I have taken sum of moments around A. And then 1200 will have also a clockwise direction, a clockwise moment, and it is equal to 1200 times 2. 981 is also having a clockwise, so it is plus 981 times its distance, which is also 3, is equal to 0, which means that MA is equal to minus 5, 3, 4, 3. Okay, so this is the moment, and this will be, of course, in a Newton meter. So this is the reaction moment at point A. Now, in order to find AX and AY, I should basically find the sum of Fx and the sum of Fy. Okay, so I know that AX plus 0 is equal to 0 because I don't have any horizontal force, and this implies that AX is equal to 0. Now I know that AY minus 1200 minus 981 is equal to 0, and this implies that AY is equal to 2181 newtons. Okay, so guys, basically these are my unknowns, MA, AX, and AY, which means, guys, MA should be flipped. Okay, so this is MA because it is negative in a clockwise, so this will be MA. AX is equal to 0, so there is no horizontal reaction in this case, even if this is effect support. However, there is no need for AX. There is no need for a horizontal reaction because basically there is no horizontal force. And AY has a positive direction that is equal to 2.1 or 2.2 kilonewton. Guys, I can guess from the first beginning of this problem that MA will be in counterclockwise. Because in fact, guys, all my forces are downward after A. So they are downward after A, which means they are doing a clockwise rotation. So in order to react and to prevent this rotation, A should do a counterclockwise, opposite rotation in order to have an equilibrium. So the support should resist all the rotation caused by these forces that are basically in clockwise. So this support should do a counterclockwise movement or a counterclockwise reaction moment in order to get to the equilibrium state. And same goes for Fy. As a matter of fact, guys, all my forces are downward, which means, guys, if I don't have a vertical upward reaction at A, my beam will fall down because of these forces. So this means, guys, that A or the support at A should resist these downward forces by an upward reaction that is equal to their sum, and that's why AY is in the positive upward direction. In the following video, we will start by solving the problems of this chapter. Thank you.